Hey guys, in this final video we will be talking about something called slope fields. So slope fields, if you want to take a look at it here, are these kind of just random dots on a coordinate plane, and they got these short little lines. And what we're going to be asked to do is change these short lines to see if they're positive, negative, maybe they're undefined, maybe they're zero. So they're just little slopes, all right? Just kind of like a graph of little slopes, if you will. All right. So slope fields correlate with differential equations like we just talked about. And they basically just tell us with a given equation what's happening to the slope in that general region. It's kind of a hard concept to understand, but basically you can just view it as kind of what's happening to the function as far as whether it's increasing or decreasing at that given point, if you will. You may or may not see this on the AP test. It was on there years ago, and then I took it off, and believe it's back on the AP test again. So just wanted you to at least have seen it before, in case you do see it on the AP test. All right, so how you're going to approach this, we're given a differential equation. We are not going to solve this like we did in the previous set of problems. Remember that dy dx, that's the same thing as a derivative, right? And derivatives at their core are slopes. So another way to think of a derivative is think of it as a slope. So what we're going to do is every one of these dots, we are going to find out the slope. Okay? So we're going to plug all these in. It's not the most fun thing to do, but we are going to do it. We're going to plug each of these points in for x and y. So all you do is plug each point in for x and y. All right. So you might see a notation. I think maybe this problem does like dy dx with a line there. And let's start at this one down here. So that point is 1 in the x, 0 in the y. So it might look like that. Dy dx evaluated at 1, 0. That just means we're plugging in 1, 0 into dy dx. Okay, so what I'm going to do is just go up to my differential equation, make it negative. Y is 0, so it's going to be 0 squared over 1. Well, that, of course, just turns out to be 0. So that means my slope at, this says the slope at 1, 0 is 0. That's all it says. So I'm going to take this line. You got to drag it right here. And I'm just going to make it a 0 slope. Oops. Just like that. Erase this here. So that's my first one. So then I'm going to just repeat this for all of them. So now I'm going to do dy dx evaluated at 2, 0. Okay, so I get negative 0 squared over 2. Well, that's going to be 0 again. So I'm just going to go ahead and take that slope. And boom. 0. Now, if this is on the calculator section, what you could do is you could plug, again, if this is the calculator section, you could make that y1. So just, well, I guess it gets a little bit complicated. Probably actually you just need to do this by hand, sorry, because you have two variables there, so it's not going to work out so well. You could do it for each line and replace the x if it's constant, but you probably should just do these all by hand. All right. So then we're going to do the next one. So let's go ahead and do this one up here. So that's 0, 1. So we'll do dy dx evaluated at 0, 1. And we'll get negative 1 squared over 0. And you'll start to see that this one and this one, where x is both 0, well, 0 is going to be on the denominator. So that means it's undefined, right? So undefined. And it will be the same for the one above it. So there is some shortcuts you get after a while here. Delete these. So undefined would be a line that goes straight up and down. Just drag these two. Straight up. Straight up. All right. So we got 4 more to do. All right, let's go ahead and do 1, 1. So dy dx evaluated at 1, 1. would be negative 1 squared over 1. So that's just going to be negative 1. So to slope, make a slope of negative 1. Well, now it's going to be negative like that. And it should just kind of be, I guess you could say even, right? Negative 1 would just be down 1 over 1. So it's just down the same amount and over the same amount. You kind of have to eyeball it, but yeah, it's going to be negative 1, 1. All right, so that's in my negative 1 slope. Let's go ahead and do the next one. So I'll do dy dx evaluated at 2 comma 1. So that's going to be negative 1 squared over 2, so negative a half. So with that one, I'm going to make it not as steep, but still negative. And I hope it, yeah. We'll see how delta math works for this. I'm going to put it somewhere in the middle there. So this would be down 1 and over 2. So that looks pretty good. I've got 2 left. For our next one, I'm going to do dy dx evaluated at 1 comma 2. So that's going to be negative 2 squared over 1. So that's negative 2. So that one's got to be a steep 1. I would guess say in the middle between negative 1 and 0 down there. All right, so like that, even steeper. And then my last one, I'm going to do dy dx evaluated at 2 comma 2. So that would be negative 4 over 2, so negative 2 again. So that one should be the same as the one next to it. So like that. All right, so let me go ahead and erase all of this stuff so you can see it. Boom. All right. So let's give that a shot and see how it works. All right, we did well. There you can see the red is, I guess, the actual answer. My slope. So this one's just a little bit off, but it's still correct because I put it in the same general correction. And over each one, you can see how they evaluated that. Okay. So they don't have to be exact. That's the good news. Let's go ahead and try one more here. All right. So we've got to plug in, looks like about 8 points again. This is in the negative direction, so make note of that. So we'll go ahead and plug each one in. So dy dx evaluated at, let's do 0 comma 0 first. That's going to be 0 over 1 squared. So that's going to be 0. So at that one, 0. Okay, let's go ahead and do then negative 2 comma 0. So we're going to get 0 over something again. So that's going to be 0. Oops. All right, let's go ahead and move up a line. So then we'll go ahead and do 0 comma 1. I would at 0 comma 1. So that's going to be 1 over 1. So that's just 1. So that one's actually already good. I don't need to move that one. It's positive 1. The next one, dy dx evaluated at negative 1 comma 1 is going to put me at 1 over 0 because I get 0 in the denominator, so that's undefined. So that one's going to be straight up and down. My next one, dy dx evaluated at negative 2 comma 1 will put me at 1 over 1, negative 1 squared, so that'd be 1. 1 over 1 is 1. So that one's already good as well. All right, and then let's do my top row. Let's do dy dx evaluated at 0 comma 2. So that's going to be 2 over 1, so that'd be 2. So I need to make that one a little bit steeper. Like that, should be good. All right, and then I've got dy dx evaluated at negative 1 comma 2. So that's going to be 2 over 0, so that's undefined. That one's going to be straight up. And last but not least, dy dx at -2 comma 2. So I get 2 over 1. So that'd be 2. So I need to make that one a little bit steeper. All right, and let's go ahead and submit. Boom, there we did. That one was pretty good. Got them all right. Very good. All right, so that is slope fields. I did throw also in some multiple choice. You've got 5 of those, creating the slope fields, and then some multiple choice questions. This is probably actually more likely what you'll see on the AP test because, well, I suppose you could have to draw a slope field, but I would guess maybe more likely a multiple choice question. So with this, here is actually what a real slope field looks like. You can see there's even more of those lines. Basically, what you want to do is just plug in some select points and see if they fit the equation. So let's take, for instance, this first one. All right, I'm going to just plug in some random points. So if I plug in, let's say the point 1 comma 0, right? Well, 1 comma 0, I know should give me a slope of, so let's write it. So 1 comma 0, the slope equals dy dx. Let's write it this way. So at dy dx of 1 comma 0, I like to start at ones where you get like a 0 or undefined slope. I know if I plug in 1, 0, I should get 0, right? So then what I'll do is I'll plug in 1 comma 0 into all these different equations and see if I get 0. So this first one here, if I plug in 1 comma 0, I would get 0 over 1, so that would be 0. So that's good for the first one. Basically any of them. So let's see. This one at 1 comma 0 would be 0 over 1, so that would work still too. This bottom one here, though, we can exit this one out because it's going to be 1 over 0, so that would be undefined at that point, which is not true. This other one would still work for 1 comma 0, so that's good. All right, and I think those would work for any of those along there. So let's choose a different point then. Let's choose maybe this point 1 comma 1. So dy dx for 1 comma 1 should give you a positive 1 slope, it looks like, right? So let's plug some of those in. Let's switch colors here. So at 1 comma 1, for this first one, it would be 1 over 1 squared. That would equal 1, so that's good. Next one, 1 over 1 equals 1, so that's good. Then 1 times 1 gives you 1, so that would work too. So they all work for 1 comma 1. All right, let's try a different one. Let's try 1 comma 2. Well, let's try a negative 1 now, actually. Let's go over here. Let's do dy dx. Evaluated at negative 1 comma 1. And that one should also give us a positive 1 slope as well, right? So let's plug some of those in. So with the first one, if I plug in 1 over negative 1, that's actually going to give me a positive 1, right? Because that would be 1 over negative 1 squared, which equals a positive 1. So we can actually rule that one out. Oh, sorry. My mistake. We can't rule that one out. We want a positive 1. So that one's actually good. So, oops. That one's good. That fits. Okay, the next one is the one we can rule out because that one's going to give us 1 over negative 1, which is negative 1, and we need a positive 1, so we can scratch this one out now. We've eliminated 2 of them. Let's try the last one down there. 1 squared and negative 1 squared both give you a positive 1, so that's one's still in the running. So we've narrowed it down to these two. We got to find some way to differentiate between these two. So let's try a negative with a negative because that should give us a different answer. Let's do this one. Let's do dy dx evaluated at negative 1, negative 1. So for the top one, that's going to give me, sorry, this should be negative 1 when you answer. So for the top one, that would give me negative 1 over negative 1 squared. So that would be negative 1. So that would work for that first one. If we tried the second one, we would get negative 1 times negative 1, which would be a positive 1. And actually, these are both squared. So we have positive 1. So that one would not work for that point. So my answer then has got to be my first question there. I never really thought slope fields were that much fun. They're kind of tedious, which is another reason why I don't like to spend a lot of time on it because I don't think it's terribly beneficial. All right, so that's the process. This one is bonus, so if you make it through all of them, great. There's a general technique. Plug in points until you find the one that works for all the points. You can feel free to watch the other video as well, but I don't think you want to watch me plug in all these points again. So good luck on that if you choose to do it. It would be a good idea. And all right, so yeah.